Let's look at this question. For the frame and loading shown, determine the component of the forces acting on member A, B, C at B and C. Look at this. A, B, C. And he said at what? At B and at C. So he wants to know the forces B and C. Okay. Let's look at this. You can see that this frame is composed of three components, A, B, C, and D, B, E, and F, E, C. These are the three components. Now, remember here there is a hinge, AX, AY, and here is the inch, 7.5 inch here, 6 inch from here to here, 9 inch from here to here, 4.5 inch from here to here, and this is a ruler, so there is a reaction here, reaction in the x-axis. Here there is two reaction. Otherwise, you have a reaction here, reaction there, and you can see the dimensions. So now, let's first of all find the reaction. You could do it like this: one force here, and one force there. Anything else? We have two reaction here, and there's one reaction there. Okay, so let's find out how many forces are in the y-axis here. Remember here there is one in the x, one in the x, one in the x, one in the x. Oh. So all of them are in the x except one in the y. So by taking summation of forces at the y, AY would equal to 0. So AY, you can see it equal to 0. Now, summation of moment, you can take summation of moment at D, because now AY is 0, so you don't have to worry about AY. Summation of moment at D, you could find AX, or summation of moment at A to find D. So you could apply this summation of moment equation by taking summation of moment at A. You could make it like this: D will move it counterclockwise, and this is the distance. This force will take it clockwise, and this is the distance, the perpendicular distance. And the force at the top, this one, moment at A, it will make it clockwise, and this is the distance. So you can see this. If you want to do summation moment at D, you could do the same thing. But summation moment at A, you could put all the things into the equation. You could get D is equal to 163 pounds. Now, if you found D, dx, you could find AX, because summation of force at X, now you could be finding 20 plus 48 plus dx minus AX equal to 0. So you could find AX at summation of force at the X. So summation of force at X equal to 0, AX is equal to 231. So now we found the reaction. We found AX, we found AY, and we find DX. Okay? So let's take the member DBE. Let's find this member, DBE. DBE, because we have DX, and now we have the force here. So let's take the member. Well, if you want to take DBE, you should do it like that. So now we take this member DBE, so we could see that there is DX, there is BX and BY, and there is EX and EY. So we do it like this. So we take it as a force like that. Let's just push way up. Okay, EX, AY, it's DBE. And the first thing we should do for this is by doing either for that DBE, taking moment at E, so by is cancelled out. You could find bx, we know D, so we apply summation moment at E, so you could find bx, and it will equal 529.75, so bx is equal 529.75, and this is the component. Look at the directions. So bx is common between two members. You can see it. B is common between ABC and between DBE. So we need to find out ABC later on. So the force of B is opposite in ABC, opposite in direction. So if the value here, we found for the DBE, we found that the BX is equal 529. So as B is a common point for member ABC and EBD, we have for member ABC that if BX is equal 529.75, it will be the same value, but it will be different direction, because it has to be different direction to be the same magnitude and different direction. Okay, so we found this value. So let's put our important member A, which is AX, BX, BY. Remember BX and BY, we have to make the opposite direction, and CX and CY. Let's take here moment at point C to find out BY, and we know AX, so we could find BY 385, and that is the answer to this question.